Students, now let us look at the example of transshipment problems. We have differentiated between the transportation problems and transshipment problems. In transshipment problems, we would have some intermediate points between the origin and the destination. So let us clarify the concept with the help of an example. For example, Calicut Supplies Corporation manufactures valves at two plants in the east coast of the United States, one in City A and one in City B. The plant at City A has a production capacity of 150 valves per day, and the plant at City B has a capacity of 200 valves per day. The valves are shipped by truck to the demand points, cities C and D, on the west coast. So we have two plants which are located at the east coast, city A and city B, and we have two destinations which are city C and city D, which are located on the west coast. The daily demand for valves is about 130, both at city A and city D. The company also operates two intermediate transshipment points at city E and F. So there are two transshipment points between the destination C and D, and they are known as E and F. And they are used to consolidate shipments when it is appropriate to do so. The unit costs of shipping valves are as follows. So we have a table from city to city. Of course, there is nothing from A to A because it's the origin point. And from A to B, the unit cost of shipping the valves is 13. This is in terms of some currency units. This is for one valve. Then from A to E, 4, A to F, and so on. Similarly, for intermediate points, from city to city, the unit cost of shipping valves are also given. Determine the best routing for shipping valves from plant to demand points. So what we need to do, we need to determine the best route. Now we can solve this problem in two phases. The first phase is to actually convert this transshipment problem into a transportation model by means of following three steps. Add a dummy row or column to balance the problem in terms of supply and demand. You would know the procedure of solving a transportation problem or balancing a transportation problem from your previous course in operations research or linear programming. Since total supply is 350 valves and the total demand is only 260 valves, a dummy column with a demand of 90 valves is added. We know that what is the total supply from city A and B? The total is 350 given in the statement. And the total demand at cities C and D is only 260 volts. So what we need to do, we need to add the column with the demand of 90 volts for balancing the problem. Now, we need to construct a transportation table by including all the cities, these are origin, destinations, and intermediate points, as supply and demand points. This will result in a 6 into 7 table, including the dummy column. So 6 rows, 7 columns table would be with us. Step 3 would be, this step actually helps to determine the demand and supply for all the points by using the following set of rules. Now, what are the set of rules? If first we need to know the nature of point in transshipment problem, whether it is a supply point, whether it's a transshipment point, whether it's a demand point, or whether it's a dummy point. Now we have 4 types of locations with us after balancing the transportation problem. So it could either be supply point, intermediate point, the destination, or the dummy point. The value of supply in transportation table would be the original supply plus the total supply. Of course, if it is a transshipment point, then it would be all about the total supply. And if it's a demand point, then it would also be the total supply. Whereas a dummy point would carry a zero value of supply in the transportation table. Now, value of demand in the transportation for a supply point would be the total supply. For a transshipment point, it would also be depicting the total supply to that point. And for a demand point, it would be the original demand plus the total supply. And also for a dummy point, it would be the original supply minus the original demand. So these are the set of rules which we need to consider. You need to know that how to deal with the value of supply and value of demand for a supply, transshipment, demand, and dummy points. So what we have the total supply in this case is 350 vols because we have balanced the transportation problem. So the resulting transportation table would be as follows. Now you can see that we have a total supply table as per the rules. The supply column has been added at the end of the table, whereas demand row has been added at the last of the table. So you would see that all the demands from A, B, E, F is 350, which is the maximum total supply. Whereas for E, C, and D, they have their other than 350, you need to add the original demand. That was 130 for C and 130 for D. So it becomes 480, 480. And dummy would, of course, in terms of demand, would be, as per the rule, it would be the original supply minus original demand. So there is no supply to it because as per the supply rule, it would be 0. So you would have the original demand of 90 for the dummy point. And supply column would be as per the set of rules as well. You can verify the supply column and the demand row. Now, after getting the transportation problem, as it is a balanced transportation problem, you can solve this transportation problem using any known transportation method. There is a Vogel approximation, there is a northwest corner method, there are other methods as well. So you can use any of those algorithms to solve this transportation problem. We also have off-the-shelf softwares that can easily solve these type of transportation problems. You need to know the concept that transshipment problems, by applying different set of rules, are actually changed into transportation problems for the ease of solving it. Thank you.